Okay, so here's an example of an oscilloscope. Okay, it's this device which can measure how the electricity is flowing through a particular object. Okay, so what you will see is in an oscilloscope is that you see a spike of electricity here. Sometimes it looks like that, That's, maybe you've seen one of these in a physics class. Probably not as complicated as this one, but something a bit smaller. But you can see this wave of electricity, a visual representation of electricity on this screen. So what it's telling us here is that you can see the first maximum value at 0 as a 4.5 amp. So we're going to have a function, okay, the electricity, so the amp, as a function of time, and it's going to be a trig function, a cosine function, because initially it's at 4.5. so let's say this height is 4.5, goes down and comes back up, and it's telling us its first minimum happens at 1 over, right? So 1 over 120 of a second. So what is the equation? Okay, note that there's no vertical shift in our curve because the maximum is 4.5 and minimum is minus 4.5. That means the middle is 0. Okay, so you can see amplitude. The amplitude is 4.5. Cosine, usually it's k. Okay, k t. There's no phase shift because we're starting from a maximum, and there's no vertical shift. And the period is determined by, the period is determined by 360 degrees divided by k. Okay, but they've told us that the first minimum happens at 1 over 120 of a second. So the full period, right? The full period would happen at twice the length, which means 1 over 60. Okay. From this, we can solve for k. Okay, so you can see that k then would have to be, right, we cross multiply 60 times by 360. Okay, so that's what we get for k. So our equation must be a is equal to 4.5 cosine of 21600 t. Of course, this is all in degrees.